Hi everyone, I'm Golden Ashwini. I'm here to present exceptions in computer architecture and organization. On completion of this video, students will be able to explain what is exceptions and explain how exceptions are handled in a MIPS architecture. Then exceptions. Control is the most challenging aspect of processor design. It is actually both the hardest part to get right and the hardest part to make fast. One of the hardest part of control is implementing exception and interrupt. Events other than branches or jumps that change the normal flow of instruction execution. So, an exception is an unexpected event from within the processor. Arithmetic overflow is an example of an exception. An interrupt is an event that also causes an unexpected change in control flow but comes from outside of the processor. So, interrupts are used by input output devices to communicate with the processor. Many architecture and authors do not distinguish between interrupt and exceptions, often using the older name interrupt to refer or both types of events. MIPS conventions uses the term exception to refer to any unexpected change in control flow without distinguishing whether the cause is internal or external. So we use the term interrupt only when the event is externally caused. Okay, in the Intel IA32 architecture uses the word interrupt for all these events. So interrupt were initially created to handle unexpected event like arithmetic overflow and to signal request for service from input output devices. So the same basic mechanism were extended to handle internally to generate accepted as well. So here are some examples showing whether the situations is generally generated internally by the processor or externally generated. What are that? Actually, the arithmetic overflow. It's an internal. Then input output device request is external. Hardware malfunctions either maybe internal or external. So invoke the operation system from the user program. It's a internal. Okay, so the operating system knows the reason for the exception by the address at which it is initiated. So the addresses are separated by 32 bytes or 8 instructions, and the operation system must to record the reason for the exception and may perform some limited processing in this sequence. So when the exception is not vectored, a single entry point for all exceptions can be used. So and the operating system decodes the status register to find the cause. For the operating system to handle the exception, it must know the reason for the exception in addition to the instruction that caused it. So there are two main methods used to communicate the reason for an exception. So the method used in the MIPS architecture is to include status registers which holds the field, that means that indicates the reason for the exception. A second method is to use vectored interrupt. In a vector interrupt, the address to which control is transferred to determined by the cause of the exception. The basic action that the processor must perform when an exception occurs is to save the address of the offending instructions in the exception program counter and the transfer control to the operating system at the some specified address. Then interrupt and exception. So first of all, interrupt is also called exception also called as interrupt, an unscheduled event that disturbs execution used to detect overflow. Then interrupt, it's an exception that comes from outside of the process. Some architecture use the term interrupt for all the exceptions. The Intel x86 uses interrupt. Okay, so we follow the MIPS convention using the term exception. So external term interrupt only when the event is externally caused. Then how exceptions are handled in MIPS architecture? So the basic action that the process must perform when an exception occur is to save the address of the offending instructions in the exception program counter and then transfer or control to the operating system at some specified address. So after performing the necessary action, the operating system can either terminate the program or continue with its execution using EPC to determine where to start the exception of the program. To handle an exception, an operating system should know the reason for exception and the instruction that caused it. So, two methods are used in MIPS architecture to communicate the reason for interrupt. First one is MIPS uses a status register or cause register which has the field that hold the reason for exception. Then vector interrupt that the operating system knows the reason for the exception by addressing at which it is addresses are separated by 32 bytes or 8 instructions and then the initiator. So the operating system must record the reason for the exception. Okay, next exception in a pipelined implementation. Actually, a pipelined implementation treats exception as a form of control hazard. For example, suppose there is a arithmetic overflow in an add instruction. So we must flush the instructions that flow the add instruction from the pipeline and begin fetching instruction from the new address. So the easiest way to do this is to flush the instruction and restart it from the beginning after the exception is handled. So the final step is to save the address of the offending instruction in the exception program counter. In reality, we save the address plus 4. So the exception handling, the software routine must first subtract 4 from the saved value. Okay, thank you. Thanks for listening.